Ever wondered how your gadgets manage to work with different voltage levels? Or how a tiny sensor can communicate with a powerful microcontroller? The secret often lies in voltage divider. If you're new to electronics, understanding voltage dividers is absolutely fundamental. And in this video, we are going to break it down for you, making it easy to understand and even easier to apply in your own projects. What is a voltage divider? A voltage divider is a passive linear circuit that takes an input voltage and produces an output voltage that is a fraction of the input. Think of it like a voltage tap. You put a certain voltage in, and you get a smaller, predictable voltage out. Most commonly, it consists of just two resistors, R1 and R2, connected in series across a voltage source, V in. The output voltage, V out, is taken across the second resistor, R2, relative to ground. It's all about how the input voltage gets divided or dropped across these two resistors. The magic happens because current flowing through series resistors causes a voltage drop across each, and by tapping into that drop, we get our desired output. Now for the exciting part, the math. Don't worry, it's simpler than you think. The beauty of the voltage divider lies in its elegant formula. According to Ohm's law, voltage equals current multiplied by resistance. In a series circuit like our voltage divider, the current is the same through both resistors. So, the total resistance is R1 plus R2. The total current flowing through the circuit is input voltage divided by total resistance. Now, the output voltage is the voltage drop across R2. Using Ohm's law again, V out equals current multiplied by resistance, R2. Substitute the expression for I, and there you have it. The voltage divider formula. This formula tells us that the output voltage is proportional to the input voltage, scaled by the ratio of R2 to the total resistance. It's incredibly powerful because it allows us to precisely calculate the output voltage given specific resistor values. Practical applications. So, where do we actually use these handy circuits? Voltage dividers can be used for sensor. Many analog sensors like light sensors or temperature sensors change their resistance based on environmental conditions. By pairing them with a fixed resistor in a voltage divider, their changing resistance translates into a changing voltage, which a microcontroller can easily read. This is how many smart devices interpret the physical world. Voltage dividers can also be used for logic level shifting. Imagine you have a 5-volt microcontroller trying to talk to a 3.3-volt sensor. Directly connecting them could damage the sensor. A voltage divider can safely step down the 5-volt signal to 3.3 volt, allowing for seamless communication. Using Ohm's law, we get R2 equals 19.4 kilo ohm. Potentiometers is a variable resistor. It can be configured and used as a voltage divider circuit. As you turn the knob, the resistance ratio changes, and so does the output voltage, controlling the volume. While voltage dividers are amazing, there are a few crucial things to keep in mind. The loading effect. This is perhaps the most common pitfall. The voltage divider formula assumes that no current is drawn from the output. However, when you connect a load or circuit to the output, it draws current. This changes the effective resistance of R2, or rather, R2 becomes parallel with your load's resistance, altering the output voltage. To minimize this, the load resistance should be significantly higher, at least 10 times than R2. Power dissipation. Resistors dissipate power in the form of heat. Ensure your chosen resistors have a power rating, measured in watts. Resistor tolerance. Resistors aren't perfect. They have a tolerance. This means their actual resistance can vary slightly, which will affect your output voltage. For precision applications, use resistors with tighter tolerances. You can watch the video I made previously for resistor color code reading so you can know the tolerance for any color-coded resistor. To really solidify your understanding, I encourage you to try building one. Grab a breadboard, a 9-volt battery, and a couple of resistors, say, 2 10 kilo-ohm. Connect them in series, apply the 9-volt, and measure the voltage across the second 10 kilo-ohm. What do you expect to see? If you remember our formula with R1 equals R2, it should be exactly half of the input 4.5 volt. You now have a foundational understanding of one of the most common and essential circuits in electronics. If this video helped you, hit like, subscribe to Alpha Electronic Lab,